Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all the solving problems. It's 9th Avenue in class again today. How have you been? On today's tutorial, we are going to look at this question on adjustment computation, and then we are going to solve it using the condition equation method of least square adjustment, right? Good. Now, before we proceed, I want to appreciate the timeless and continuous effort of Said Olani, popularly known as Saga. Thank you so much, sir, for all you do for solving solutions regarding adjustment computation. Now we have this set of angular observations where we have about 6 observations, right? Good. Now we have the first angle, we have the second angle, we have the third angle, right? Good. Now, having observed those 3 angles, a fourth angle was also observed, and then that fourth angle actually covers the first and the third angle, right? Good. That's angle 1 and angle 3, and then the fifth angle covers what? The second angle and what? The third angle, right? Good. That's angle 2 and angle 3, right? Good. And then we have the sixth angle, which covered what? The first, second and the third, right? Good. Now you need a writing material and a calculator by you, and then you also need to what? Follow it through to the end, right? Good. So these are the values of each of the observations. We have theta 1, theta 2, theta 3, theta 4, which is what? 1 plus 2, theta 5, which is what? 2 plus 3, and then theta 6, which is what? 1 plus 2 plus 3, right? Good. Now we have a formula to use for the condition equation method of least square adjustment, where our v is equal to minus, we have a bigger bracket, b transpose, into a smaller bracket, b multiplied by b transpose, then that bracket closes, we have an inverse of that multiplied by w, and then we close the bigger bracket. So as you can see it here, this formula would be used for what? The condition equation method of what? The least square adjustment. So where the b is a matrix of what? N by m, and then the w is a matrix of what? N by 1, right? Good. So your n is the number of conditions slash parameters, whereas your m is what? The number of observations, right? Good. So these are some foundations that we need to build. These are some fundamentals that we need to appreciate, right? Good. Now, so from the question, we have the following conditions. So while we are trying to read out the question, we also read out the condition, in that yes, we have 3 observations, right? Good. Now, so from these 3 observations, the summation of 2 will give you the 4th and the 5th what? Observations, and then the summation of 3 will give you what? The 6th observation, right? Good. So now this can help us what? Write out our conditions. So the first of the conditions we have is that the adjusted value of angle 1 plus the adjusted value of angle 2 would give us what? The adjusted value of what? Angle 4. Right. Good. Similarly, the adjusted value of angle 2 plus that of angle 3 will give us what? That of angle 5. And then finally, the adjusted values of angle 1, 2 and 3 would give us what? The adjusted value of what? Angle 6, right? Good. So this is just what we have been explaining earlier, right? So if we have stated it like this, we can now just take everything to the left hand side by, let's say, collecting like terms, right? Good. Now remember, this first set of expressions which we have just read out, we are equating it to still observed angle, right? Good. So if we take all observed angles to the left hand side so that we just have a number on our right hand side, we can now rewrite what we have earlier as what? The adjusted value of angle 1 plus the adjusted value of angle 2 minus the adjusted value of what? Angle 4 equal to 0. This simply means this angle 4 adjusted crosses over the equality sign and becomes negative, right? Good. And therefore we have 0 here. So that's what we have done for what? The second, and that's what we have done for the third, right? Good. So minus 5 is introduced here because the adjusted angle 5 crosses the equality sign and it becomes minus, and then we have what? 0 here, right? Good. So we have actually run it through what? To angle 1 adjusted plus angle 2 adjusted plus angle 3 adjusted minus angle 6 adjusted equal to 0, right? Good. Now we are going to introduce the errors, right? Good. Now by errors we know that that is why we are carrying out the least square adjustment. All observations would contain a measure of error. What the least square adjustment does is that it tries to reduce it to the barest minimum, right? Good. So we have the observed angle 1 plus the residual or the error that is observed with it plus the observed angle 2 plus the residual minus, remember at this point we have minus, right? Good. So that's the essence of this minus. And now you know when you're working with minus, you need to be careful so that it covers everything. So we have to introduce what? A bracket. That's why there's a bracket here. Remember the other ones that are having their residuals, we did not introduce a bracket because they are all addition, right? So now since a negative sign has been introduced, we need to introduce a bracket so that the negative sign can have effect on every other thing inside of the bracket. Are we together? So we now have minus angle 4 observed plus the error equal to 0, right? Good. So we have run it down. We have angle 2 observed plus the residual plus angle 3 observed plus the residual minus what? Angle 5 observed plus the residual equal to 0. And then finally we have what? Angle 1 and the residual, angle 2 and the residual, angle 3 and the residual, right? Good, because that is what this equation, right? That's this equation. Then minus angle 6 observed plus what? The residual of 6, all equal to 0. Are we together? Now when we simplify further, which means we want to open this bracket, or we have opened this bracket, and then we have also what? Collected like terms. By collecting like terms, we have moved all the observed angles to one side, and then we have also moved all the residuals to one side, still on the left hand side anyway, right? Good. So what the further simplification has done is that we now have, okay, let's start from the beginning. We now have theta 1 plus theta 2 minus theta 4. How is this theta 4 negative? Because this minus has opened this bracket. Remember we told you some minutes ago why we have a bracket, right? Good. Now this minus has what? It has opened this bracket. Therefore we now have what? Theta 1 observed plus theta 2 observed minus theta 4 observed, right? Plus we have the residual v1, v2 and minus v4, because this minus has effect on everything that is what? Inside of this bracket, and this theta 4 and then the v4 are all inside of the bracket. Therefore they now have what? Negative signs in the further simplification. Are we together? So we are running it down again. We have theta 1 observed plus theta 2 observed minus theta 4 observed plus residual 1 plus residual 2 minus what? The residual 4, all equal to 0, right? Good. So if we do that of the second line, we have what? Theta 2 observed plus theta 3 observed, then minus what? Theta 5, then plus the residual 2, residual 3 minus what? Residual 5, all equal to 0, right? Good. So I know you're familiar with this now. So we have what? Theta 1 plus theta 2 plus theta 3, which is what? 1, 2, 3. Then minus theta 6, which is what we have here. Then plus v1, v2, v3 minus what? V6. That's what you have seen here. All equal to 0, right? Good. Now, by adding up, what do we mean? You know, these angles, they have values, right? Good. These are the values, the observed angles. These are their values, right? Good. So since we have sorted them out, we can now decide to substitute these values into the equation, right? Good. So that simply means that's why you need your pen and your calculator by you now, so that you can actually what? Start pressing your calculator, which is very, very important, extremely important. So we now have to say theta 1, which is 35 degrees 18 minutes 14.67 seconds, plus theta 2, which is 40 degrees 25 minutes 38.09 seconds, right? Good. When you add those two together, you subtract it from theta 4, which is what, 75 degrees 43 minutes 53.52 seconds. So if you have done that correctly, you are going to have what, minus 0.76 seconds. Are we together? Now, how did we write, or how did we rewrite it like this? We have it like this because when you have V1 plus V2 minus V4, you don't know the values, right? Good. So you are not going to add anything. There are no values stored for them. There are no values known for them. So you are not going to simplify them. However, these theta values, they are known. Therefore, when you simplify them, you can decide to bring all of these V to the left hand side of your left hand side anyway. By viewing the screen, you would understand. By writing them first, then you now write what the result of the addition, or let's say the simplification of what your observed angles, right? Good. So because if you look closely, the observed angles came first before the residual. However, as we went down to add, we are having the residual before the final value that we got from what the simplification of what the observed angle, right? Good. Now this is also important because the result is negative, so that we don't have issues with, okay, starting with minus 0.76 seconds plus V1 to get things a bit messed up, right? Good. So these are some things that you just need to appreciate so that you understand better what we have done or what we are doing. So to proceed and then to re-emphasize, you do angle 1 plus angle 2 minus what, angle 4 as observed and as written here. So you are now going to have what, minus 0.76 seconds, right? Good. So you just write the residuals and then you now say minus the last value, which is a result of this simplification, all equal to 0. So we are doing that for the second line. So we have what, angle 2 observed, which is this 40 degrees 25 minutes 38.09 seconds, plus angle 3, which is 66 degrees 38 minutes 17.63 seconds, right? Good. Minus angle 5, which is what, 107 degrees 3 minutes 57.23 seconds. So if you have done it correctly, you are supposed to have minus 1.51 seconds, right? Good. So rewriting it as we have explained earlier, we have what, V1 plus V3 minus V5 minus that value you got, all equal to 0. And then finally we have what, theta 1 observed plus theta 2 observed plus theta 3 observed minus theta 6 observed, which is what, 35 18 14.67, 40 degrees 25 minutes 38.09, then 66 degrees 38 minutes 17.63 seconds, all added together, minus 142 degrees 22 minutes 11.92 seconds, right? Good. So if you've also done that correctly, it will return a negative value of a negative difference of 1.53 seconds, right? Good. So you now rewrite it as it is being displayed. Please, if you miss it at any point, we always emphasize that you pause the video, you rewind, and then you can even drop comments on the comment section so that we can see how best we would help the further simplification, right? Good. So now let's form the matrices. The solution is by using matrices, right? Good. So let's form our matrices. So the first matrix we are going to form is the B matrix. Now we have the 6 unknowns, right, which is this V1, V2, V3, V4, V5, and V6. That is what we are trying to solve for, right? Good. The values of V1, V2, V3, V4, V5, and V6, which we are now in turn going to apply to what, our observed angles, right? Good. So, and we have told you that our B matrix is actually what, n by m matrix, right? Good. Which is the number of conditions by the number of observations, right? Good. So in your matrix we have rows going from left to right by columns going from top to bottom, right? Good. So we usually have a note by the side of each of the matrices that shows the dimension, or that defines the dimension, or that identifies the dimension of the matrix that we are working with. So this B matrix is actually what? A 3 by 6 matrix, because we are having 3 rows, 1, 2, 3, and then 6 columns, which is 1, 2, 3, 4, 5, 6. Right, good. Now, how do we form this matrix? The formation of this matrix is as simple as whatever we have been doing. So let's come to this, our last set of equations. Now, in this our last set of equations, we have V1, V2 minus V4, and then minus 0.76 seconds. Right, good. So from this equation, we have extracted all the residuals, the unknowns that we are trying to solve for, which is from V1 to V6. So we are now going to look at the coefficient of these residuals in this equation. Right, good. So in equation 1, the coefficient of V1 is 1, so we have 1 here. The coefficient of V2 is 1, so we have 1 here. We don't have V3 here, therefore it is 0. We have V4, and then the coefficient is what? Minus 1, so we have minus 1 here. We don't have V5 and we don't have V6, therefore V5 and V6 are zeros. Right, good. Don't worry, if you miss it, you will get it in the equation 2 and equation 3. So we come down to equation 2. Similarly, the coefficient of V1 here is 0 because there is no V1, but we have V2, and then the coefficient is 1, which is what? This one. We also have V3, the coefficient is 1, which is this one. Right, good. We don't have V4, therefore the coefficient of V4 here is 0, but we have what? A V5, and then our V5, the coefficient here is minus 1, that is this minus 1 we have seen here. Right, good. And then we don't have a V6, therefore the coefficient of V6 is what? Is 0. Are we together? Good. Now we come to the third equation, which has V1, V2, and V3. Therefore the coefficients as we have on the matrices are well written down. We have V1, V2, and V3. However, we don't have V4 and V5. Therefore their coefficients are what? 0. So we have 0 here and we have 0 here. But we have V6. Right, good. So the coefficient of V6, as we can see here, is minus 1. Therefore you see what? Minus 1. Right, good. So that is how we form this B matrix. Can we proceed? Good. So now let's come to our W matrix. Right, good. So this matrix is n by 1, and then it is formed by further simplifying what? The observed angles. Right, good. So by further simplifying the observed angles, so whatever remnants that you have gotten here, adding 1 and 2, subtracting from 4, adding 2 and 3, subtracting 5 from each other, and then adding 1 to 3, and then subtracting angle 6 from it. So that is what forms what? Our W matrix. Right, good. So as we add them here, we just simply extract and populate our W matrix. Right, good. Now recall the formula for V as stated earlier. So this is the formula we are referring to. Recall the formula because we have all the parameters we need for the formula. The parameters are B and W. Right, good. So every other thing you want to do with this inside of this formula has to do with B and W. So that's why we are telling you to recall, because we want to start what? Using the formula. So the very first part of the formula is for us to find the transpose of B. Right, good. So we are going to proceed to Excel very soon, but let's just take this transpose. So the transpose of B simply means changing the rows to columns, the rows to columns, and then the rows to columns. Right, good. So if you change this one to column, you have this, you have this, and then you have this. Right, good. So now let's see you on Excel. Good. So we are on Excel now, and then we have imputed what? The elements of our B matrix. Right, good. And then we also have what? Our L matrix. So from where we came, what we want to achieve is what? B transpose. Right, good. So we have what? 3 by 6, which is 3 rows and then 6 columns. Therefore the transpose will be what? A 6 by 3 matrix. Right, good. So we have what? We need to define a 6 by 3 matrix. So we have 1, 2, 3, 4, 5, 6. Then that still serves as column 1, 2, 3. So we have defined what a 6 by 3 array. So we have equal to transpose. So we now highlight our B matrix. Then we have Control Shift Enter. So we have what transposed our B matrix, right? Now coming back to the formula again, the next part of it is what B multiplied by B transpose, right? Good. That is this part of it. So the reason or the essence of having the dimensions of the matrix is that it helps us to know what the product of the multiplication of two matrices will be. So since matrix B is what a 3 by 6 matrix, which we have seen here, and then the matrix B transpose is what a 6 by 3 matrix, which we have seen here. Therefore their product will return what a 3 by 3 matrix, right? Good. So for this product of B and B transpose, we are going to define a 3 by 3 array. Now the manual methods of carrying out multiplications, inverse, and some other operations in matrices are on the channel, so we are going to drop special links to some of those videos, and subsequently we are also going to make some new videos if possible to explain these procedures or these processes to you, right? Good. So check the description section to see how you can carry out matrix multiplication and then inverse of a matrix, right? So we are going to define a 3 by 3 array on Excel. So this is 1 cell 2 3, then this is 1 2 3, right? Good. So we have equal to m mult, which is what the multiplication of two matrices, right? And then the order is B by B transpose. So we highlight B, comma, and then we have what B transpose, right? Good. So we have Control Shift Enter. So this gives us the product of what B and then B transpose, right? Good. So the next part of it is to find what the inverse of this product, and then the inverse is simply what the adjoint over determinant, right? Good. So we have told you, check the description section so that you can see the manual methods of what carrying out this procedure. So we are now going to find what the inverse, right? Good, of this our last product. So we still come back here. The inverse will still be what a 3 by 3 matrix. So we have equal to M inverse. So we have matrix inverse. It returns the inverse matrix of a matrix stored in an array. So we have something like this. Then we highlight what our matrix. So we have Control Shift Enter, right? Good. So this is the inverse of this matrix, right? Good. So the next part of the formula is for us to now multiply this inverse which we have gotten by B transpose. Remember, we are still trying to what solve for V, right? Good. So we are taking it one step at a time, right? Good. So we are now going to multiply this inverse we have gotten by B transpose, right? Good. The order is very important. So we have B transpose multiplied by this inverse, right? Good. This inverse multiplied by B transpose is not equal to B transpose multiplied by this inverse. It is very, very important to know that. So we have B transpose multiplied by this inverse. And then what is the dimension? We have actually stated it here. The B transpose is what a 6 by 3 matrix, and then this inverse is a 3 by 3 matrix. Therefore the product will give us what a 6 by 3 matrix, right? Good. So you have seen the simplification. So we're having what 6 by 3 left. So we are going to define what a 6 by 3 array on Excel, and then we go with B transpose times what the inverse. So a 6 by 3 array will be, we have cell 1, so we go the 6 rows, we have 1 2 3 4 5 6, and then 3 columns that serves as column 1, column 2, and then column 3. So we have equal to m mult, which is this. So what's our B transpose? Our B transpose is this. Then we have comma, the inverse, which is what? Which is this, right? Good. So we have Control Shift Enter. So it has returned the product of B transpose multiplied by B transpose inverse, right? Good. So that's this inverse, then this is what the product. Now we're almost getting to the tail of the tutorial. Since we have achieved this, we can now couple things up to get V, right? Good. So the last part of it is to multiply everything that we have gotten by W, right? Good. Which is what this 3 by 1 matrix, right? Good. So if we are having a 6 by 3 matrix, which is this last product, multiplying what a 3 by 1 matrix, which is a 6 by 3, 3 by 1. So we should be able to have what a 6 by 1 matrix, right? Good. So we are now going to define a 6 by 1 array on Excel and then carry out what this set of matrix multiplication, right? So a 6 by 1 array will be, that's 1, 2, 3, 4, 5, 6. These are the 6 rows, and then we just have what a single column. So equal to mmult, whatever we have here, then comma our W, right? Control Shift Enter. Good. So the final multiplication returns this, right? Good. Which is as a result of coupling things up, we have B transpose multiplied by B times B transpose inverse, then multiplied by W, right? Good. Which is what a 6 by 1 matrix. So these are the elements of what that particular matrix. Now if we come back to our equation, or if we come back to the expression we used to solve the problem, we are going to see that we have a negative sign that multiplies the whole of the expression, right? Good. So whatever value we have, we are still going to multiply it by what a negative sign, right? Good. So that means we now come back here again, equal to minus this, right? Enter. So we are now going to do that for all other values. So it's simply by multiplying whatever result you have by -1, right? Good. So if you say -1 times the whole of this, it returns these values, right? Good. So this is because we have what this negative sign here, right? Good. So the next part of it is that on your calculator you can actually have something like 0 degrees, 0 minute, 0.195 seconds, right? Good. The reason being that we want to convert or change the values that we have here for our V to degree, minute and seconds, so that we can apply them to what the observed angles, which are also what in degree, minute and seconds, easily, right? Good. Easily. So if you now say 0 degrees, 0 minute, 0.195 seconds on your calculator, it should be able to give you this value, right? Good. That's 0.2 seconds. So if you do that for the second V2, that's the second value of V, it should be able to give you what 0.57 seconds down to what to V6. So what this means that this is for V1, this is for V2, this is for V1, this is for V2, V3, V4, V5, and then V6, right? Good. So we are now going to apply these corrections to what, to our observed angles, right? Good. To get the corrected angles of each of those observations. So on your calculator you can follow me through. We have for observed angle 1, we have 35 degrees, 18 minutes, and then 14.67 seconds, right? Good. So what do we do? Plus 0 degrees, 0 degrees, 0 minute, 0.2 seconds, right? Good. So we have 0 degrees, 0 minute, 0.2 seconds, right? Good. So on your calculator you should be seeing 35 degrees, 18 minutes, 14.87 seconds, right? Good. So that's how we are going to run it down to V6. So you still come again, 40 degrees, 25 minutes, 38.09 seconds, plus 0 degrees, 0 minute, 0.57 seconds, right? Good. So you are supposed to have this value down to, let's now come to V5, because V5 is a bit different. We are adding. However, since the sign that is for V5 is negative, therefore it will be subtraction. So let's say we have 107 degrees, 3 minutes, 57.23 seconds minus, it's actually an addition, but plus times minus will give you a minus. That's why it is now minus, right? Good. So do not apply a negative correction to these ones. They are all additions. However, because of this negative sign, the addition has changed towards a negative sign, right? Good. So we now have minus. So we now have 0 degrees, 0 minutes, and what's the value here? 0.37 seconds. So we have 0.37 seconds. So that should return 107 degrees, 3 minutes, 56.86 seconds, right? Good. So you do that for V6, and then these are the corrected angles. So let us run a check. That's one of the basic principles of surveying. If you have gotten to this point, you have done a fantastic job. You can leave I got here, right? Good. You can just type I got here on the comment section so that we know that you appreciated our effort up till this point, which is actually encouraging to us, and it's very, very important to us as well, right? Good. So if you have gotten to this point, you have actually gotten or calculated the adjusted values of your observed angles. However, you need to apply a check, because we have some conditions here that the adjusted value of 1 and the adjusted value of 2 must give you the adjusted value of 4 with maybe very minimal discrepancies. Similarly, that of 2 and 3 must give you 5, and then that of 1, 2, and 3 must give you 6. So these are the adjusted values or the corrected angles. So now let's come for the check. Now for the check, the conditions have been stated. The angle 1 adjusted plus the angle 2 adjusted must be equal to the angle 4 as adjusted, right? Good. So what we have done here is that we have written out the adjusted values, which we have just shown you here. We have written them out here, as well as the adjusted value of 4, because the adjustment was applied to all the observed angles, right? Good. So to the adjusted value of 4. So we now added these two. So you can also add 35, 18, 14.87 plus 40, 25, 38.66. So whatever you have on the left hand side is this value. You are now comparing it to what is on the right hand side, which is what the adjusted value of theta 4. So you can see we have 52.53, and then we have 53.53, and then we have 53.52. So the difference there is about 0.01 seconds, right? Good. So that's quite allowable. Then we come down to the second condition, which is what adjusted 2 plus adjusted 3 equal to adjusted 5, right? Good. That's the adjusted angles, right? So for the left hand side, we are going to add them up, and then we need to also have equated this to adjusted 5, right? Good. So and adjusted 5 is what? 107,356.86, right? Good. So we have 107. Okay, we have 107,356.80. So when you add up everything on your left hand side, you can see that what they are equating, right? Good. Now finally, let's do that of what the third condition, which is adding 1, 2, 3, and then equating it to what? To 6, right? Good. So we have angle 1, angle 2, and angle 3 equated to what? Angle 6 as adjusted, right? Good. So we now have 142, 22, 11.73 equal to 142, 22, 11.73, right? Good. So this gives us what? A check, right? Good. That the adjusted angles are now what? Adding up. So if you still want to go further by taking the right hand side to join the left hand side so that you now have equal to 0, you can still do that to see if you are going to have what? 0. So thanks for coming to class. This was quite exhaustive. It was as detailed as possible. We hope you had your writing material and your calculator with you. We hope you were following us through to this point. And once again, thank you for everyone who would have watched from the beginning up till now. you have done a fantastic job for yourself, and you have also encouraged us. So we have shown you on today's tutorial how to use the observation equation method of least square adjustment to solve a problem of angular observations, right? Good. To get the adjusted values of what these angles, right? Good. These observed angles, which are these values you can see here. Then we have also performed a check, which is one of the basic principles of surveying, right? Good. So we are going to see on the next tutorial. We have so much in stock for you. Ensure to share with your friends, your colleagues, your students, so that everyone can have the very best of this tutorial. Have a very good time. Bye.